we want to try and factorize the following cubic function, remembering how we did that from a couple weeks ago, now that it's getting up to week 8 now. So remember we used the remainder theorem and the factor theorem, that where we have a cubic in this form, we call this D, we call that A, and we only want to check factors of D divided by A, which is going to be 6 divided by 1, which is equal to 6. So we only want to try factors of 6. Now, you guys tried them all and you figured out that 2 of them work, okay? You figured out that f of -1 equals -1 plus 4 take 1 plus 6, which is equal to 0, and f of 2 equals 8 take 16 plus 2 plus 6 equals 0. So we know that x take -1 is a factor. And I'm writing it as take -1 because we want to remember that we take away the number that is the factor. And that x take 2 is a factor. So right now you can take your pick and pick either one of those. But you know that both of them are going to be a factor in the end. But I'm just going to stick with -1 because that's the one I've done the solutions to. So we know that we have x plus 1. Because take a negative number, we get plus 1. And that gets me to ax squared plus bx plus c. I'm just writing it in general form right now. We have something times x squared, and that has to be x cubed. So what does that first one have to be? What's the coefficient of my x squared inside? 1, because 1 times 1 is 1. The coefficient of x cubed is 1. So a is just equal to 1. What is c going to be equal to? 6, because the final numbers all have to be multiplied together. So now we just have to worry about my b. So it's x plus 1 times x squared plus bx plus 6. And now we know we have to relate b back to some of the other ones, okay? So b is equal to, now remember, let's just set it equal to all of that. What are going to be our coefficients? So b of x, do you all remember how to do this, or do you want me to go through it the long way? Yes, no, maybe? We'll do it the long way. Got the time. So if I expanded that out, it's going to get me x cubed plus x squared plus bx squared plus bx plus 6x plus 6. Now, we know that this all has to equal x cubed take 4x squared plus x plus 6. So our x squared and our bx squared have to add to give -4x squared, and that is how we can find the value of b. We can also relate x's, but I always just like doing the x squared. Don't ask me why, but I just do. So -4x squared equals x squared plus bx squared. Well, I'm going to add take negative over here. So it's going to be -5x squared equals bx squared. Therefore, b equals -5. Yes? Okay. So now I can write my final factorized cubic as x plus 1 x squared take 5x plus 6. And then I can factorize x squared take 5x plus 6 even more. Because what are the factors of 6 that add to give -5? -2 and -3. So finally, my factorized cubic will be x plus 1, x take 2, x take 3. And that is as factorized as you are expected to get it. Okay, you don't need to find the values of x where it equals 0 because that's not what the question asks. Okay, the question just says factorize it. Okay, so just be wary because if you take it one step further, you may get the question wrong because you may not have understood the question. Okay, so just be aware of what we're reading. Finishing off our booklet today. So I'm going to press that notes link. No, and it's going to take me to here. All right. So the diagram below shows the graph of the function y equals f of x and 4 key points on the graph. We've got 4 coordinates here. We've got A, negative 8, 0, B, negative 5, 9, C, 0, negative 4, and D, 2, negative 6. Okay. Now, I'm going to keep the video on here for a second. And what we need to do is copy the coordinates on top of our page. So, copy the coordinates up here because we need the coordinates, otherwise we're going to be scrolling back and forth the entire time. So we want the coordinates negative 8, 0. We want the coordinates negative 5, 9, and just write them above that A, B, C, and D on our table. I'll just give you a little bit to do that while I discuss what the question is actually doing. So we're going to have a table and we're going to have lots of different transformations, and we need to try and figure out the new coordinates after every transformation has taken place. So now that we've all got that copied down, I'll copy it myself after I make these all skinny. That's all I should need right now. So this one is negative 8, 0. This one is negative 5, 9. This one is 0, negative 4. And here we have 2, negative 6. So, first thing we want to try and figure out is what the transformation has done. So we have f of x here. F of x is the graph that we have sketched. We don't know the formula. We don't know the equation. We just know that it's a function of x. Well, if I add 3 onto the end of it, what transformation has taken place, Nishk? We've moved up 3. So for the first one, all I'm doing is going up 3. If I go up 3, does that change my x-coordinate? Does that change my y-coordinate? Your y-coordinate goes up by 3. So negative 8, 0. Negative 8 is still going to be there. But what's my new y value, Hannah? Because I just go up 3, right? Here's going to be negative 5, 6. Sorry, negative 5, 12. Sorry, negative 5, 12. 0, negative 1. And 2, negative 3. Every point has just moved 3 units up because that is where the graph will end up moving. Just that 3 units up. What about f of x take 2? Liv, what's happening there?
It would go to the right, 2 to the right.
2 to the right? Now, are we adding that constant in with our x, or are we adding it to the end of the function?
Oh no, it would go 2 down.
It's going 2 down. Remember, it needs to be inside my bracket to be moving left or right.
Yes.
So it's 2 down. We're moving down 2. So all that's doing is just making us go down 2. So negative 8, negative 2, negative 5, 7, 0, negative 6, 2, negative 8. All right. 3 f of x. Ollie, what transformation has occurred if we have 3 outside of that f of x?
It's dilated.
It's dilated, by a factor of what? Dilated by 3. And I'm going to write those two lines. Do we know what those symbol for that two lines means? Parallel. Parallel to what axis? It's parallel to the y-axis. We've dilated by 3, parallel to the y-axis. Now I'm just going to write in shorthand here because I don't have the much space, but we all understand what I'm talking about. So what will my coordinates for A dash be if I've dilated by 3 in the y-axis, Pat?
Times x.
If I'm getting taller and shorter, what am I what coordinates am I changing? Remember, x is left or right. That changes how far. I'm timesing the y coordinates, yeah. So it's -8, and what's 0 times 3? 0. X is going to stay the same here, and that will now be 27. 0, -12, and 2, -18. Because I'm just changing all of my y coordinates by a factor of 3. Yes? What am I doing to the next one, Riley?
You're reflecting it and dilating it. Like
Yeah, so it's dilated by 2. And it's been reflected. Reflected on what axis? It's reflected on the x-axis, okay? So my value of my y-coordinates are going to swap because I'm reflecting on the x-axis. So what's going to be my new coordinate of point A? Hannah. Yeah, it doesn't change. If you have a point on the axis and you reflect it on the axis, that's not changing at all. So it's still going to be -8, 0. Ollie, what about point B?
It'll be 5.
Have I moved my x positions at all, or am I just changing my y?
-5.
It's still -5. I'm only changing the y position.
And then 18.
18. Because I double it, and then I change the sign. Oh, actually, sorry. No, it should be -18. I double it, and then I change the sign. Since it's 9 in my original point, I have to double it, and then flip it across that x-axis. 0, 8, 2, 12. Does everyone understand how I got to those 4 points? Okay. Now we're changing it to f of 2x. Now, if I'm inside the brackets, what is it changing?
on the y. Parallel. No, it's the x.
It's changing my dilation factor parallel to my x-axis. Inside the bracket, it affects x. Outside the brackets, it affects y. So my next one is going to be dilated by. By what factor is it being dilated if it's inside my bracket? If I have that 2 there, something's changing. We're not dilating by a factor of 1, something's changing. Let's look back a couple pages. It's going to say it in that general page form. It'll be a page and it'll have the general form of the equation. It's literally just one page back, guys. If I have that number inside that bracket, what's my scale factor going to be? It's a half. It's 1 over that number. So it's dilated by a half parallel to the x-axis. So what's my new A going to be? If inside my bracket changes x, and I dilate by a factor of a half, I'm dividing the number by 2. -4, 0. then that's going to be negative 5 over 2, 9, 0, 8, 1, 12. As you can see, I'm just going to be getting a little bit closer to that y-axis. What's this next transformation that's occurred? Riley?
Reflected over the XY axis.
Over the xy axis?
Over the Y axis.
Over the y-axis, yeah. Reflected over the y-axis. If I'm reflecting over the y-axis, remember, y is my vertical line. And so if I'm swapping sides, is that changing the x-coordinate or is that changing the y-coordinate? It's changing the x-coordinate. Okay? If I was to bring this up, right? Let's say I have negative 2, and that's going to be reflected on the y-axis. Sorry, positive 2 reflected on the y-axis goes to negative 2. So it just changes the coordinates of that x function, the x-coordinate, sorry. So all these now just swap signs. It's going to be 8, 0. It's going to be 5, 9. It's going to be 0, negative 4. And negative 2, negative 6.
Wait, sir.
Yes.
The one above, and we divided do we divide everything, all, like, each coordinate by 2?
Just the x-coordinate by 2. Because you're only changing the x-coordinate.
Oh, okay. Then why for the last 2 did you times them by 2?
Because if we have that number in here, so I'm just going to write the general form. So f of x equals, so a outside of f of, hold on, I'll just copy it down the way it's written. So I'll just change this f of x to y. So y equals a outside of b x take c plus d. Oh, that just looks stupid. There we go. Plus d. Okay? If I change a, that dilates in y. It changes my y coordinates. If I change d, it goes up or down, changing my y coordinate. If I change c, that moves me left or right, changing my x coordinate. If I change b, it changes my x. However, b dilates by a factor of 1 over b. That's just the rule that takes place. Remember when we were talking about our transformations yesterday, or maybe it was the day before, and we have this situation here. And we said that negative 7, negative 4, so you know that function of x when negative 7 equals 4. Well, now we want to find out the function of 2x that equals negative 4. So we have to divide that x coordinate here by 2 to get the new transformed coordinate. That's why it dilates by a factor of 1 over the number, which is why we divide these coordinates here by 2 now. Yep?
Yeah.
Okay. F of x take 4, what is that doing to my function, Nishk?
Moves like x right.
So we're moving the whole graph right 4. So this just translates my graph right 4 units, which just changes those x coordinates. So negative 4, 0. Negative 1, 9. 4, negative 4. 2, negative 6. Oh, sorry, 6, negative 6. Sorry, 6, negative 6. Now, if I have that positive there, f of x plus 1, what transformation is happening there, Ollie?
It's moving one to the left.
1 left. Left 1. So if I'm moving 1 to the left, this now will become negative 9, 0. This is going to become negative 6, 9. Negative 1, negative 4. 1, negative 6. Okay? So now we have only been dealing with one transformation occurring to the graph. It's probably not going to be that easy. They're probably going to give you more than one and combine them together. So this is where we really need to know what each transformation does. F of x take 2 plus 4. What's happening to the graph, Pat?
It's going 2 to the right.
Going right 2
4 up.
and 4 up. So we now just move each coordinate right 2 and up 4. I'm just going to scroll down so I can see the bottom. So now we're changing both the x and the y coordinates. We need to be really careful what's happening. So this now becomes negative 6, 4, because we're moving 2 right and 4 up. Negative 3, 13. 2, 0, and 4, negative 2. What's happening with my next one, Hannah?
It's dilating by 2 and it's moving up 3.
So it's dilated by 2, and then we're moving up an additional 3 units. Okay? Me personally, I always like doing the dilations first, because then you just move the entire graph up. If you move it up and then double it, like, it may just confuse you a little bit, and so I always like doing dilations first. So the coordinate is negative 8, 0. So if the coordinate is negative 8, 0, and I dilate that by a factor of 2, what's my new y coordinate going to be before I move up or down? It's still going to be 0. I can't dilate 0 anymore because it's just on the axis. So it's going to be negative 8, 3. Pat, what is the point of b going to be when I dilate it by 2 and then move it up 3? We're still going to have negative 5 as my x because x hasn't changed right now.
Negative 5, 21.
21. I times it by 2 and then I plus 3. 21. Ollie, C?
All of it.
Just this one.
Yeah. It will be 4. No. It will be 0.
Yes?
Negative 1.
Negative 1?
Positive 2.
Positive 2. That's a big difference.
Negative 5.
Why negative 5?
Because that's what math says.
Mav, why'd you say negative 5?
Because you times the y coordinate by 2 and then add 3.
Yeah, you times the y coordinate by 2 and then we plus 3. The y coordinate is negative 4. If we double that, we get negative 8. And then we move up an additional 3 units. And lastly, this is going to be 2, negative 9. Because it'll be negative 12 after we double it, and then we add 3. Now, I'm just going to highlight these two. Okay? And we're going to talk about it after we do the first example. Nish, what transformation has occurred?
Dilated over.
Oh, I know.
Dilated by how much? By a half, exactly. So it's dilated by a half. And then what?
And right 4.
And right 4.
Would it be 8?
No. Hold on that. So it's dilated by a half and then right 4. We're just following this general form up here.
Oh.
And this tells us that if it's C there, we move C units right. Right now, we are still in that form. We're going to move C units right. So we dilate by a half and then right 4. What's my first coordinate going to be, Hannah? 0, 0. Half of -8 is -4, and then moving 4 to the right gets me to my origin. Liv, what's going to be the second one?
So it would be 5 over 2, then. So would it be -1, -1/2?
Not -1/2, because you've added 4 onto 5, but it's actually 5 over 2. So what do we have to do to that 4 in order to add the fractions together? So we've divided -5 over 2, because that's what the dilation occurred. And then we have to add 4 onto that, moving it 4 to the right. Well, how do I add those two numbers together? I have to change the 4 somehow into what? And how do I change 4 into a fraction over 2? So 5 over 2 plus 4 over 1. And what's that 4 over 1 going to turn into?
Oh, does it become 3 over 2?
It turns into 3 over 2. Yeah. -5 over 2 plus 8 over 2 gets me to 3 over 2. So this here is 3 over 2. And then the y coordinate is going to stay the same. Pat, next coordinate, please.
Does it just go? Because you go 0 times 2. And then... Is it 4 and -4?
It is 4 -4. Timesing it by 0 doesn't actually change anything, because 0 is just always going to remain 0. And then we just move it right 4. And lastly, Ollie, can you do the last one for me?
It's 1/2.
Not quite.
1.
So we half it to get 1. And then what do we do?
Move 4 to the right.
Which gets me to what? 5, -6. Okay? Now we're going to talk about these two differences here. These two functions look incredibly the same. The one main difference is that the 2 is outside of my brackets here, and this one is that the 2 is inside of my brackets. And this is just transforming f of x. The first thing we want to try and figure out is what the transformation actually does. So let's just go and try and use an actual example. Let's just say that my function of x is just going to be y equals x, right? So then I can start typing these in, and I'm going to type in the two different ones. My first equation is going to be y equals 2x plus, 2 outside of x take 4. Enter. And that gets me a line there. Next up is going to be y equals 2x take 4. Which is going to be here. Alright? And I'll keep those functions there. 2x take 4 here, right, has moved me how many units to the right? 4, because that's our general function that we accept. Now 2x take 4, I can rewrite that somehow.
Oh, you factorize.
I factorize out the 2. So if I factorize out the 2, it's going to get me to y equals 2 outside of x take 2. Which means I'm now moving 2 units to the right, which is what's happened with here. I've moved 2 units to the right because that is the general form that we accept for that general equation of a function transformation. So now we're going to go back to our functions. And what transformation has occurred to this function now? We've dilated by a factor of what? We've still dilated by a half. And we've moved to the right how much? 2. We've moved 2 to the right. So now it's going to be -2, 0. -1/2, 9. 2, -4. And 3, -6. Liv, what's happened with my next one?
So it gets reflected and then it moves 3 to the right.
Reflected and 3 right. So it's going to be -8, -3, -5, -12, 0, 1, and 2, 3. Now I just realized the time, so we probably want to get through these just a little bit quickly because I feel like the video is going to start lagging on me a bit soon. So we got 3f of 2x. We're now combining transformations in x and transformations in y. What's one of the transformations that's occurred, Nishk? Dilated by 3 in y. Okay, so dilated by 3 in y and by a half in x. So we've dilated by 3 in y and a half in x. Now we're going to have to change both x and y coordinates. Ollie, what's my first one going to be?
First one is going to be
I don't know why you cringe. It's actually an easy one.
-4,
Yep.
0.
-4, 0. We half the x value, we triple the y value. That's all we do for all of these points. We half the x value, triple the y value. That's going to be -5/2, 27. That's going to be 0, -12. That's going to be 1, -18. We figure out what we do to each coordinate, and then you just do it to that coordinate. Dilating by a half means you divide it by 2. Dilating by 3 means you times it by 3. Now there's the last one.
And then all the coordinates. That would be the question.
This will be the test question. This is going to be the question they ask you to see if you understand what all of these transformations do. We have a total, and I'm going to go a different color now because this is a special occasion. We have a total of 4 transformations that have occurred. Okay? So, what's the first one that's happened? What's any one of them that's happened? So dilated. Actually, I'm going to take that back. There are 5. Dilated by 2 parallel to y. Next one. Reflected on the x-axis. So we've dilated by 2, then we've reflected it because the coefficient is -2. What's another transformation that's happened? Dilated by a half in x. Fourth one, 1 to the right. And last, up 5. So, my recommendation, isolate the x variables, isolate the y variables. Do them separately. What do you have to do to y? What do you have to do to x? And get to a final answer. For those watching at home, I recommend that you pause right now because I'm going to give these guys some time to work on it, okay? I just realized that it didn't really work out. I'm just going to stay silent on here for a while, okay? So I want you guys to have a go at doing these yourself. And I'm just going to walk away from the headset. Honestly, I think I'm going to do it a lot more. Like, even after all this. It's kind of invaluable if people aren't here.
Maybe not every lesson.
So like it's
Not-
before
certainly not
everything's
yesterday.
over.
Not
You'll
yesterday.
still have your little headset on.
Now he'll upgrade.
Just coming like you're like Ben's class, headset on.
Sad and no one's listening to you.
Got 0 views for 6 months.
People cry.
Mate, I'm above subscribers now. Like, not happy.
So do you know what I'm thinking? I reckon you should do like a collab with Gemma and YouTube channel. How funny would that
Yeah, your mic's still
Yeah, I know. They're just going to have to deal with some laughing for a bit. Suck on it, you're not having fun.
So these guys can do some work in the class.
Oh. Okay, we're serious again.
I have to listen back.
Alright. So, what's going to be my first coordinate? Has anyone figured it out? Ollie.
Is it 5? 5.
The y coordinate is going to be 5. Nishk? 3? Negative 3. Negative 3, 5 is the first one. Okay? Let's just talk about the x coordinate. We divide it by 2. And then you go to the right 1. You divide it by 2 gets to negative 4. Then you go right 1. So our y coordinate now, you're reflecting it. So it goes from 0 to 0. You double it. Well, that's still 0. And then you add 5. So negative 3, 5. What's my next one going to be? So let's just do x first. You half it, and then you add 1. So we divide negative 5 by 2, so it's negative 5 over 2, and then move 1 unit to the right. Not a half. Negative 3 over 2. Negative 5 over 2 is going to be half of it. Then moving 1 to the right means you add 2 over 2. So negative 3 over 2. And the y coordinate is negative 13. Okay, you're going to flip 9 to get negative 9. You double that to get negative 18. And then move up 5 units to get negative 13. One, 13. 1, 13. Dilating x on the origin doesn't make a difference. Then we move 1 to the right, making the x coordinate 1. And then doubling the value of negative 4 gets me to negative 8, then positive 8, and then up. So 13. Last one, 2, 17. All right. So now, hopefully, we have a pretty good idea of what all of these transformations do. They do different things, and you need to isolate them differently. The easiest way to work on them, if you've got x's and y's put together, so transformations of x and transformations of y put together, is isolate each coordinate.